MetReport. Okay, this function, what it does, it cleans the EMS report, keeping only one compound per retention time based on the difference of the expected retention time and the real retention time. So the expected retention time is the one that you have in the library, and the real retention time is the observed retention time, the one that EMS reports when it was identified. And this function also recalculates the abundance of each metabolite. Test report, and then here I have MetReport. I don't know, here in this case you have the description of the arguments that you need, but if I don't want to change anything, I just put MetReport and enter. Again, it's going to ask me where the CDI files are. So in this case, I have to point to the main folder, which is example Metab. So that's my main folder. It's where I have the subfolders for each experimental condition. So I select this main folder and click on choose. Now it's asking where is the EMS library. So I go to work, point to my EMS library, which is example Metab. So I choose the EMS library and click on choose. It's converting to the new library, and now it's asking me where is the EMS report. So I go to work, and then Metab bioconductor, and my EMS report is here. That text file that we generated using EMS. Remember, that's the file. So I select this file and click on choose. So it's now analyzing the files. As you can see here, it generates the chromatogram of each file. So we have only 10 files, it's pretty quick. Can close this one. And here it's saying that generated one file here, that's called Metab data, and another file here, that's the log file. So let's just have a quick look at these files. So one file is here, Metab data. So that's, as you can see now, that big report with the results on top of each other, now they are combined in a single spreadsheet in a way that you can use for further analysis. So you have in the first column the name of the metabolites, and then in each column here you have the abundance of those metabolites in the different samples. And here in the first row you have the name of the experimental condition related to each sample. Okay, so it does that automatically because you divided the samples here in different folders. So what the package does, it identifies the folders and knows that those files here were coming from this folder. Okay, and the log file is a very simple file where you have here the folder that was used as project folder. Now in this case here, example Metab, the main folder. Tells me what's the EMS report that was used, the file, what's the ion library that was used, what's the result file, so Metab data. Here we have one parameter called time window, the date when the report was generated. If some metabolites were removed, I will tell you now what it is. And here the abundance, that in this case here is the abundance of the reference ion number 1, which is the most abundant reference ion. Cool. So, however, you can change so you can apply MetReport like this, but when you apply like this, you to use the default configuration of this function, which in this case, if I do question mark MetReport, it shows me all the configurations that I can change for this function. So MetReport has those arguments here. One of them is data folder, where I show what's the main folder. I have to define here where is the main folder, which in our case here is example Metab. EMS report must receive is a way to show where is the report that we generated with EMS is located. We have ion library, where we show where is the ion library is. we have here the argument save, which can be true or false, which means if we want to save the results or not to a CSV file. If true, this output here takes the name of the file that will be generated. In this case, the default is Metab data. That's why the data set here is called Metab data. You can choose, you can change if you want. And time window is a threshold defining what's the limit between expected and observed retention time that you consider to accept the identification of a compound. So in this case 2.5, so every compound that has an observed retention time 2.5 minutes higher or like after or before the expected retention time will be removed from the analysis. So that basically tells me what's the limit for the difference between expected and observed retention time. And remove gives you the option to remove from the analysis some of the compounds that you don't want to analyze for some reason. So for instance here, let's suppose that I don't want this compound here called xylene. So let's see the result. So as you saw before, the results here in this data set. Okay. However, the result is also here in R. So if I put MetReport, test report, that's the variable that we used. So the same report that you have here in the file, we have here in R, the same information. Let's suppose I don't want xylene 3 to be in the report. Okay, so I can run the same analysis. So let's repeat the process quickly. So MetReport, and let's put here remove equal xylene 3. So I don't want that compound in my analysis. Or even better, I can say I don't want any xylene in my analysis. It will remove every compound that has xylene in its name. So in this case I want to remove only xylene 3. So let's see how it works. Again, it's going to ask me for all the information. So first it's asking me for the main folder. So the main folder is here, choose. Now it's asking me for the ion library. So the ion library is here. I can choose the one you generated before just to show you that it works as well. And now it's asking me for the MetReport. So the MetReport is in here. And now it's going to analyze the files in the same way. Okay. However, because we had already the first data set generated here, it won't replace the file, so it generates a new file with the same name, however, with the addition of 1 here. So if I look for the results, test report, which is the variable that we use here to save the results. So now xylene 3 is not in the results. So it's out. If you see here the difference in the file as well. So xylene 2 and the first file xylene 3. So it's not there anymore. So Metab gives you this option to analyze, to point and click in the files that you want to use, like the MetReport, the folders, the library, and so on. However, it's quite time consuming anyway. So the best way I suggest is actually to tell the function where the file is beforehand, like this. So here, instead of point to the file, I can just say the MetReport. Let's go again to the help file, and let's define each one of its arguments. So the first one is data folder. So it's the main folder. Where is the main folder? It's this one, example Metab. So let's go here. I want to know where is this folder. This folder is this thing in this path here. Beautiful. And then here I will say that the main folder stay with me, don't get lost. So the data folder here is in this path. Example Metab, M's report. Where is the M's report? So the M's report is in the same folder. However, I have to add this information here, the name of the M's report. Now it's asking me where is the ion library that we are going to use. So the ion library again is in the same folder, however it's a different file, so I can copy and paste and just change the name of the file. I can choose the MSL file or the ionlib, doesn't matter, anyone is going to work. So that's the file. Now I can choose if I want to save or not. So first of all, let's say save equal false. I don't want to save. And here I can change the name, but in this case I'm not going to save the file, so it won't make any difference. Here I can change this time window. I think 2.5 minutes is too high. It's a very large difference between expected and observed retention time. So I want to reduce that to let's say 0.5. Actually the GCMS we work here is quite reproducible, so 0.5 is more than enough. And I don't want to remove any metabolites. If I want to remove, so let's say that I want to remove then, just to show how it works. In this case I want to remove 2 metabolites, not only one. I want to remove acetone, and I also want to remove ethanol. Those metabolites will be removed. And the results generated by MetReport will be associated to this variable here, test MetReport. So if I run this file here now, it's running, converting the library, now analyzing each of the files the same way, and it's done. So as you can see, it doesn't say that it saved any file, because save was false. And if I see the result, if I analyze this variable here now, I have the same results I had before, but now I don't have acetone and I don't have any more ethanol because I removed them from the analysis. Okay. If I want to save the results, I can put here true. In this case, I can define the output. I'm going to change the name of the results. So the output, I will give a name testing Metab and analyze again. Analyzing. And you have the results. Now we have the message here saying that results were saved to this folder. So you have the log file and the testing Metab. So if I see here in the folder itself, I have Metab and here testing Metab, which is our new function, new result. I can open that in Excel if I want. It's a CSV file. So here is all the result. Let's make it bigger so everyone can see. So again, here have replicates. In replicates you have the name of each condition. So those are the replicates related to condition 50 microliters, and these are the replicates related to 100 microliters. Okay, and again I don't have acetone and I don't have ethanol because we've removed them from the analysis. Okay, those are the results.